Eighth grade, welcome back. It's week 12 and we're still talking about energy. The end of the week, we'll be talking about waves and how waves transmit energy. We'll be talking today about how energy is actually converted from one form into another. So we should be able to explain that by the end of this lesson. Here we see Sari and Danielle. They're spending a stormy Saturday afternoon with cartons of hot popcorn and a spellbinding movie. They are obviously too focused on the movie to wonder where all the energy comes from to power their weekend entertainment. They'll give it some thought halfway through the movie, though, when the storm causes the power to go out. Watching movies, eating popcorn, and many other activities depend on electrical energy. Most electrical energy comes from burning fossil fuels, which contain chemicals or stored chemical energy. When fossil fuels are burned, the chemical energy changes to thermal energy, and the thermal energy is used to generate electrical energy. These are all examples of energy conversion. Energy conversion is the process in which one kind of energy changes into another kind. When energy changes in this way, the energy isn't used up or lost. The same amount of energy exists after the conversion as before. The energy conversion obeys the law of conservation of energy, which states that energy cannot be created or destroyed. Besides electrical, chemical, and thermal energy, some other forms of energy include mechanical and sound energy. Additionally, we have nuclear energy, which is included at the bottom of this picture. Often one form of energy changes into two or more different types of energy. For example, the popcorn machine changes electrical energy into thermal energy. The thermal energy in turn changes both mechanical energy and sound energy. The popcorn machine changes electrical energy to thermal energy, which heats the popcorn. The heat causes the popcorn to pop. You can see that the popping corn has mechanical energy of movement. It overflows the pot and falls onto the pile of popcorn at the bottom of the machine. The popping corn also has energy. That's why it makes the popping sound. Mechanical energy commonly changes between kinetic and potential energy. Kinetic energy is the energy of moving objects. Potential energy is the energy that is stored in objects, typically because of their position or shape. Kinetic energy can be used to change the position or shape of an object, giving it potential energy. Potential energy gives the object the potential to move. If it does, the potential energy changes back to kinetic energy. That's what happened to Sari. After she and Danielle left the theater, the storm cleared and they went for a swim. That's Sari in the picture coming down the water slide. When she was at the top of the slide, she had potential energy. Why is that? She had the potential to slide into the water because of the pull of gravity. As she moved down the slide, her potential energy changed into kinetic energy. By the time she reached the water, all of the potential energy had changed to kinetic energy. So, how could Sari regain her potential energy? Pause the video for a moment and think about it. Welcome back. Sari could climb up the steps to the top of the slide. It takes kinetic energy to climb the steps, and this energy would be stored in Sari as she climbed. By the time she got to the top of the slide, she would have the same amount of potential energy as before. So can you think of any other fun examples of energy changing between kinetic and potential? Think of a playground. What are some things that happen on a playground that are examples of energy changing between kinetic and potential energy? Well, some examples include things like swings, slides, and trampolines. So in summary, energy conversion is the process in which energy changes from one form or type to another. Energy is always conserved in energy conversions. Different forms of energy, such as electrical, chemical, and thermal energy, often change to other forms of energy. Mechanical energy commonly changes back and forth between kinetic and potential energy. So, how did you do? Can you now explain how energy is converted from one form to another? If so, by all means, move on to the next activity. If you're still a little bit unsure, go ahead and go back to the video and view it one more time. Thanks for watching.